through running different scenarios, and one of the scenarios which we never expected to see was an actual reduction in the flood releases. The desired state of the system is in a zero to low risk state under normal flood release conditions. However, in a scenario where 50% of the flood releases was reduced, and it's this blue line over there, the blue line over there, one can see that the risk that the ecosystem, or the risk posed to the ecosystem to maintain its provision of protein sources for the local communities of an acceptable quality and quantity has moved from a zero low risk to a moderate going into a high risk that those provisions cannot be maintained. So the science is telling us that people are not going to get the provision of ecosystem services that they are used to. However, what's the current situation? 2 weeks ago, we undertook a survey to the Pongola floodplain system, and the flows are extremely low, less than 5 cubic meters per second, and it should be around about 8 cubic meters per second. However, it's business as usual on the floodplain. So the people do what the people have been doing for the past 15 years, even though there is a drought. What we have, however, found is that there's actually an increase in what's happening on the floodplain. In the town of Ndumo, there's an increase in the agricultural activities with new irrigation schemes coming on board, and there's non-stop irrigating of the land. There is road construction taking place in the area, and the water required for road construction is abstracted from the Pongola River. Just on the slide, I've shown that there's a berm that's been constructed into the river, which is approximately 80% of the width of the river, damming up the river so that these trucks can come and pump water, and it's only used for construction. The question, of course, arises, so how has the water use license been allocated for road construction as well as increased irrigation in a system where you have below baseline required flows? What was always evident when you go into the town of Ndumo is the local vendors selling deep-fried tilapia. The deep-fried tilapia has now been replaced, because the pans are all dry, with deep-fried Russians and deep-fried chicken. So the fish, which is a traditional source of protein on the floodplain, it doesn't appear to be a problem that there's not the fish resources aren't there. People have adapted, went on to a new source of protein. The Nyamiti pan, which is one of the largest pans within the Ndumo Game Reserve, there's a little picture of it over there, has reduced in size to about 15% of its original 200 hectares surface area. It used to maintain the largest population of Nile crocodile in South Africa. Of course, those large numbers, 300 odd Nile crocodile, aren't there anymore. They've moved on. Where have they moved on to? What is evident from the surveys that we did is that the Pongola River, even in its dammed up state, lower flow state, plays a very important role as a refuge for fish and crocodiles within that system. So much so that the surveys that were conducted now, for the first time, we were able to sample 2 fish species that had last been sampled in 1983. So it means that those fish have always been there. They've probably moved up from Mozambique, and they've moved into this area where there is more water at this stage. So what it actually shows is, in a system which we have modeled to be in a highly degraded, high-risk stage of not supporting ecosystem services, actually appears to be in extremely good nick. So how is it that we as scientists, and with all of these tools that we've developed, cannot necessarily see eye to eye with the decision makers, people awarding the water licenses, people allowing for the abstraction to take place? And what I'd like to do here is actually make use of some of the literature produced by the environmental management people, and this is specifically related to how do we, and Kevin, this is where, thank you very much for your presentation, because I think it's much more eloquent than I'll be able to put it when we start looking at sustainability and if we look at adaptive management. Our opinion as scientists is usually that when we provide the tools, we do the management scenarios, this is based on rationalism. So therefore we reckon that because we've got good information, we'd be able to make good decisions. And the more information we have, the better decisions we have. And of course, this is based on normal science, where uncertainty is not incorporated into the decisions that we make. The normal science is positivism, theory-based decision making, where the assumption is, of course, that the decision makers display rational behavior, that the system understanding is very good, and that we are able to distinguish between cause and effect, and therefore there's no uncertainty, there's no ambiguity within the decisions that are made. It's very clear that this is indeed not the case. So even us as researchers who think we've got a handle on things, we don't have the handle on things. So the whole management of the system is not, and the management of water resources is not based on rational decision making. It's post-normal science. Now, what is post-normal science? Post-normal science and decision making is where you have to make decisions in the face of uncertainty. And it's usually when you make decisions in the face of uncertainty, it's when you manage plurality within and outside of science. And this is where Tally Palmer has been doing a lot of work lately, where if you have low decision stakes, low system uncertainties, then we're applying science. However, a lot of the work that we're doing and a lot of the water resources management that's taking place and the training and the skills required is actually where you have to make decisions where the stakes are high and decisions where the uncertainties are high as well. So what we need to do is we need to start extending the internal and external peer community. So it's not just pure scientists that we're engaging with anymore. It is now people outside of science that need to be convinced. And earlier this morning it was spoken about, how do we actually do knowledge dissemination? How do we do implementation? And it's these components that we need to start addressing in order to make the difference, in order to provide the science to make good decisions. Oops. So it's the concept of resilience that needs to be embedded into this post-normal science and decision making. Now, resilience, just quickly, ecological resilience just is the magnitude of the disturbance that can be absorbed before the system changes its structure, and therefore it's the ability of the socio-ecological system to persist and to adapt. Now, a lot of our water resources management strategies and the way that the ecological reserve is seen is based on this relative to a reference condition. It's the whole bounce back ability to a stable endpoint, baseline-led thinking. Now the question is that the baseline where we want to be? Is that the baseline that we can afford? Is that actually the baseline that the system requires? Because the Pongola is showing us that if we want baseline, we need a lot of water, but it's still a system which is in a fairly good state. So the alternative, of course, is this evolutionary resilience thinking, which is shown through the adaptive management cycle.